I'm almost finished with the test. Not quite. I'll have them. I was hoping to have them to give them back to you, but I'll have the grades posted maybe about an hour after class. Okay, so shouldn't. I don't think it'll take me any longer than that after class. So tomorrow's the last day to drop. So I know some of you might be mulling that over, so I'll try and give you that information so you can have that. Okay. It's not quite as serious in here because you do have the option of the final replacing one lower test grade. So, but I'm trying to have that to you. Okay. Okay. So this section, the section I normally do with another section on the same class meeting, but I think we'll just do this one today. So we shouldn't be here the whole time. Anything today. Okay. All right. So section 3.3. This is our last section out of chapter 3 that we'll cover, and then we'll go and do some out of chapter 4 for the rest of our stuff. So in 3.3, we're doing division. Okay, we're doing division, but we're doing division with polynomials. Okay. So if you remember how to divide numbers, okay, especially if you remember how to do long division, which I know is you don't use every day, right? I don't. If I'm having to do long division, I get out a calculator, like everybody else. Okay, but if you remember the process of doing long division, it works the same way with polynomials. It just looks different. We're actually going to look at 2 ways to divide polynomials. So you can do the long division method, and it always works. Or sometimes there's another method that will work in certain situations called synthetic division, and we'll look at both of those. Okay. Most of the problems I've got in the assignment, you can use either one. I think there are only 2 out of the 11 where you have to do long division. The other ones you can choose whether you want to do long division or if you want to do synthetic division. Okay. So we'll look at those 2 methods. Okay. So there's this thing called the division algorithm. Okay. And the division algorithm says if we are going to take a polynomial, so p of x, okay, and divide it by another polynomial, we're going to call d of x. Okay. When we do that, we're going to end up with something that looks like this. We'll have a polynomial called q of x, and we'll give all these a name. There's a reason why they all start with these letters. Plus r of x over d of x. Okay. So this looks a little bit more confusing because we've got polynomials involved. They're not just numbers. Okay. But all these things are d of x in both situations. It's the same polynomial. It's the one we're dividing by, so that's called the divisor. Okay. When we divide, the answer we get is what we call the quotient, so that's q of x. And then sometimes if we're dividing and it doesn't divide out evenly, we have some left over. That thing we have left over we call the remainder. Okay. So all this is saying is if we take a polynomial and divide it by another polynomial we're calling the divisor, we'll get a quotient. And it's possible if we have something left over, if it doesn't divide evenly, we can have a remainder left. And then this is just one way to write that down. Sometimes, like if we were doing long division with numbers, we want to divide 3 into 28. Our divisor's 3, and if we divide that, we would have a remainder of 1. So there's 2 ways you could write that answer down. You could say our answer is 9 with a remainder of 1. Sometimes you may have done it like that way back. Or you could say our answer is 9 plus 1/3 or 9 1/3. So in that case, we're just taking the remainder and writing it over the divisor. That's all this thing's doing. All right. Okay, so we can do all this with polynomials. Okay? Let's do a quick one with just numbers, just to kind of, it's probably been a while since you've done long division by hand, if you even remember doing it. Okay, so let's do a division problem here, not that big. We'll do 281. Okay. So what we do is we take our divisor and we say, okay, we're going to see how many times this will go into our first digit. On this one, it won't. Okay. So 0, and we don't have to write down the 0 up there because it's the first digit. Okay. So then we would say, okay, well, since it won't go into 2, how many times will it go into 28? Okay. And in this case, it'll go in 9 times. And so we would write the 9 up above the 8. And we do 9 times 3. It'll give us 27, so we write that down underneath. And then we want to subtract, so we put our minus sign out there. Okay. We subtract, so that gives us 1. And then we bring down our next digit. So we have 11. And then we just kind of do the process over again, except we're looking at how many times 3 will go into 11. Okay. So 3 will go into 11 3 times, so we would write the 3 up there. 3 times 3 is 9. We want to subtract, so we put a minus sign. 11 minus 9 is 2. And then 3 won't go into 2 because we're 2 smaller than 3. So this is our remainder. And then again, there's a couple ways you could write that. One way to write that is we say, okay, our answer is 93. That's the part up at the top. And then we can write the remainder over the divisor. So that would be 93 and 2/3. You could do it as a decimal with numbers. Well, you'll see. We really only have fraction forms, really our main option on these. So, well, actually, there are a couple problems where WebAssign has one box that wants the quotient, so that would be like the 93 on this one, and then one box where it wants the remainder, so that would be the 2/3. And then on the other problems, you would just put like 93 and 2/3, but it looks a little bit different with polynomials. But. All right, so we're going to do the same process, but our divisor and the thing we're dividing, the dividend, are both going to be polynomials. Okay? Definitely polynomials. So let's look at one of those. So we're doing long division, what this is called. So we want to divide, or maybe we don't want to, but we are going to. Okay? Divide 3x squared minus 10x minus 3 by x minus 3. So if it's written this way, the one we're dividing by is our divisor. That's the one that's going to go outside the symbol in front. And then the thing we're dividing is the part that goes underneath the little house symbol or whatever you want to call it. Okay. So setting this up, we would have x minus 3 out front, and our little division symbol, and then 3x squared minus 10x minus 3 underneath. Okay. So we're going to start off the same way. Okay. Our divisor, all we really have to look at, okay, we just have to look at the leading term out here. So we don't worry about the minus 3 just yet. We're just going to look at the x term, and then we're going to look at the leading term inside. So we're going to look at the 3x squared term. Okay. So we're going to say, one way of asking the question is how many times will x go into 3x squared? That may be a little hard to think about. Another way of wording that is, what would we have to multiply x by to get 3x squared? Okay. So if we've got an x and we need to get to 3x squared, what would we have to multiply by? We'd have to multiply by 3 for one thing. And then to make x be x squared, what else would we need? We would need a 3 to get 3x. And then what else? X. That way, when we multiply, if we did 3x times x, we would get 3x squared. That's what we want to happen. Okay? If that's confusing to you, another way of thinking about it is we've got 3x squared on the inside, and we want to divide that by x. Okay? If you do that division, one of the x's cancel, and we get 3x. You can think about it that way too if you want to. Okay. So we got the 3x up there. So now, just like before, we're going to take the 3x and multiply it by the divisor. The only difference here is our divisor has 2 terms. So it's like we're having to use distributive property. So we'll do 3x times the first term and then 3x times the second term. Okay. So we'll do 3x times x, and must have touched something on the smartboard there. I don't know what it is. So we'll do 3x times x. We'll get 3x squared. We already knew that's what was going to happen. And then we do 3x times negative 3. We get negative 9x. Okay. The next step in the process is we want to subtract. Okay. So before we only had one number, so we could just put a minus sign. Okay. A way that's maybe a little bit easier thinking about it with polynomials is that we're going to change all the signs, right? So we're going to change that to minus and that to plus. Okay. And then we can just combine like terms. That's the same thing as subtracting. Okay. So 3x squared minus 3x squared, 0, so we don't have to write that down. Then we've got negative 10x plus 9x. That's going to leave us with, going to leave us with negative 1x, or just negative x. Then we can bring down our next number, which is minus 3. And then we just do the process again. So we're looking at x out front. We want to know what would we have to multiply that by to get negative x. So if we got x and we need negative x, what can we multiply by? Somebody help me. Negative 1. Yeah, negative 1. Okay. And then if we multiply, we do the negative 1 times the x, we get negative x. We do negative 1 times negative 3, we get positive 3. And we want to subtract, so the way we can do that is we can change the sign, so plus x minus 3. Okay. Combine like terms, so negative x plus x, that's 0. Negative 3 minus 3 will give us negative 6. Whoops, negative 6. Okay. And that's going to be our remainder. The way I know that we're finished and that's going to be our remainder is that the degree of this thing, we don't even have an x, so that's really degree 0, okay, is smaller than the degree of our divisor. This is degree 1. Okay. So as soon as you get something left over where the degree is smaller than the degree of the thing you're dividing by, then you're finished. You're finished. So 2 ways we could write this answer down. Okay. We could either say our quotient is 3x minus 1, and our remainder is negative 6. Okay. Or another way we could write that down, I'm trying to think about the best place to put it here, is we could say we got 3x minus 1, and then always a plus. The remainder, which was negative 6, over the divisor, which was x minus 3. Okay. So either like that or like that. So some of them on WebAssign will give you 2 answer boxes and let you do it like that. Some of them will ask you to write it down like this. You can do just 1 answer box. Or type it in like that. Okay. Questions on, need to back up and walk back through any of that one? No, you good? Yeah. So after you multiply, then whatever you get, you just switch the signs. That's the same thing as subtracting. Yeah. So you just switch the signs and combine like terms. Same thing as subtracting. Okay. Let's do another one like this. Okay. Here, I'm going to write it this way. I'm going to say we want to divide, but p of x, the one we're dividing, 2x cubed plus 8x squared minus 4x minus 1. And our divisor, the one we're dividing by, is x plus 5. Okay. So if we're setting up our division, x plus 5 is going to be the one that goes out front. We've got our division symbol. And we'll put the other one under there. So, same process. You know, if we've got x out here, what will we have to multiply by to get 2x cubed? So I know we're going to need a 2. Write that down. And then to get from x to x cubed, got to have x squared. Okay. 2x squared. Now we multiply. We got to multiply every term in the divisor. Okay, so 2x squared times x is 2x cubed. These should always match, okay, when you multiply. If not, we did something wrong. Okay. And then 2x squared times 5 would be 10x squared. Okay. And then what's the next step? Change our signs. Yeah, change our signs because we want to subtract. So minus there, minus there. Okay. So then 2x cubed minus 2x cubed, that's 0, so that goes away. And we got 8x squared minus 10x squared. That'll give us negative 2x squared. Okay. What's next? Bring down the next term, yeah, so bring down minus 4x. And then do it all over again. Do it all over again. We want to know what should we multiply x by to get negative 2x squared. Now I need a negative 2. And I'm trying to get from x to x squared, so I need another x. Okay. And then I want to multiply my divisor by negative 2x. Negative 2x times x, negative 2x squared. Negative 2x times 5, negative 10x. Change the signs. So plus and plus. So then negative 2x squared plus 2x squared is 0. It goes away. Negative 4x plus 10x is 6x. We're going to go one more time. So bring down minus 1. Okay. So what do we need to multiply x by to get 6x? One's not too bad. We're going to multiply by 6. Yeah. So 6 times x is 6x. 6 times 5 is 30. Change our signs. Six x minus 6x, that's 0. That part goes away. Negative 1 minus 30, negative 31. And that's going to be our remainder, because here this is degree 0. We don't have an x. Our divisor was degree 1, so since this degree is smaller, we're finished. So either we could say, depending on how it wants to answer, either our quotient is 2x squared minus 2x plus 6, and our remainder is negative 31. Or we could write it 2x squared minus 2x plus 6 plus negative 31 over our divisor, which was x plus 5. Any questions? Need to go walk back through any? if you can get the steps down, it just happens over and over again. So it's not, even when they're longer, they're not harder. It's just longer. Okay. All right, one other thing to mention here, and this really applies to doing it long division like this or doing synthetic division. Let's look at one more. So we've got one like this. Okay. We're not quite ready to start on this one yet. Okay. And we didn't have to think about it on the first two we did because we had enough to think about. Okay. There's one other thing we need to be aware of when we're setting these things up, and that is that we need, starting with whatever the biggest power of x is we have, we need them to go down by 1 each step. So here we had x to the third, x squared, x to the first, x to the 0th, or no x. Okay. And the same thing here, we had x to the first, x to the 0th. Okay. That makes everything line up the way we need it to. Here we got x to the third. We're missing an x squared. We're missing an x to the first, and then we've got the x to the 0th, or the no x term. So before we can really do this division, okay, what we need to do is we need to put in some placeholders where we're missing some x terms. Okay. So we got x to the third, that's fine. But then we don't have an x squared term, so what we can do is we can put in plus 0 x squared. We're also missing the regular x, so plus 0 x. And then we can put in the minus 64. If we were missing any powers of x in our divisor, we would need to do the same thing. We would need to put placeholders in there as well. Okay. Makes everything line up, makes it a whole lot less confusing. Okay. And the zeros are not bad because the, addition and subtraction with those is easy. If we were going to do this one, let's say, what should we multiply x by to get x to the third? That'll be x squared. X squared times x, x to the third. X squared times negative 4, negative 4x squared. So see, now that lines up underneath our placeholder and everything's where it needs to be. And we can change our signs. X cubed minus x cubed goes away, just 0. Then we got 0x squared plus 4x squared, so that's just going to be 4x squared. And it's a little bit weird, but now we're going to bring down our 0x term. Get that out of the way. All right, I'm going to do it over again. So x into 4x squared. That'll be 4x, what we need to multiply by. 4x times x is 4x squared. 4x times negative 4 is negative 16x. Change our signs. 4x squared minus 4x squared goes away. Then we got 0x plus 16x, so that's just 16x. Bring down our next term, minus 64. X will go into 16x 16 times. 16 times x is 16x. 16 times negative 4. Okay, so that's a little bit big. You can use a calculator. Okay, it's negative 64. Yeah. Change our signs. 16x minus 16x, that's 0. Negative 64 plus 64, that is also 0. This one went in evenly, so no remainder. Okay. So our answer on this one is just x squared plus 4x plus 16, no remainder, so we don't have to write down the weird fraction term. And if it asks us for our remainder, we would say 0. Questions on those? Okay, so let's look at our other method. Okay, long division always works. You can divide any polynomial by any polynomial using long division. But you know, it takes up a lot of room and it takes a minute to do. Okay, so that's kind of the downside. Our other option, sometimes, called synthetic division. The big downside to synthetic division is that it only works in certain circumstances. Okay. Synthetic division only works with the divisors when the thing we're dividing by so it only works when our divisor looks like x minus some number. But note, x plus c is just x minus negative c. So really what we're saying, if we have just an x with a 1 coefficient plus or minus some number, then we can do synthetic division. And let's see, in the assignment, 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 11, you can use synthetic division if you want to. Okay. So synthetic division seems a little strange. We're really doing the same thing as long division. We're just kind of, really the only difference is that we're writing down like the bare minimum information that we can write down. So we're not even going to write down any x's when we get it set up or anything like that. We're just going to deal with the coefficients. So it looks a little weird. But a lot of people like it better than long division. So let's look at one. We'll do synthetic. Okay. So this one we can do with synthetic division because the thing we're dividing by, our divisor, has a 1 coefficient, leading coefficient, and then we just got x minus some number, x plus some number, so synthetic division will work. Okay. So to set these up, the setup's the important part. Okay. If you get everything set up correctly, they go pretty quick. And you really don't have to write down all that much, but you got to get it set up correctly. Okay. So the first thing we're going to write down, we're going to look at the thing we're dividing by. This is x minus 5. So I'm going to write down the opposite of that number. It says minus 5, so I'm going to write down positive 5. And you got to take the opposite there. So I'm going to write down 5. And then there are a couple different symbols people use for synthetic division. I think the most common is kind of, it's like a big L, or almost like taking the other division symbol and flipping it upside down. Okay. We're going to have 2 rows of numbers that go in here. Okay. The top row, okay, is just going to be the coefficients off of all the terms of the thing we're dividing. Okay. No x's, just the numbers, just the coefficients. So first we'll have 4, and then minus 16, and then minus 12, and then plus 5. Oh, we don't have to put the plus, just 5. Okay. So my top row is going to look like this: 4, minus 16, minus 12, 5. Okay. So the thing people forget is take the opposite. If you put minus 5 out front, you're going to get completely the wrong answer. Okay. Also, something you have to keep an eye out for is, just like with long division, if we're missing any powers of x, you would need to put in a 0 as a placeholder in these places. This one had them all, right? We had 3, 2, 1, and then 0, no x. So we didn't have to put any placeholders, but if you need placeholders, you got to put zeros in their spot, that top row. Okay. So questions on getting that set up so far? Okay, so from here, it's just a little bit of arithmetic. Okay. The first number on the inside, the 4, we're going to bring it down to the bottom. Okay. And then what we do is we multiply 4 times 5, 5 out front. So the 4 at the bottom times the 5 out front will give us 20. And that 20 we write underneath the next number. And then you can either think about it like we add or we combine like terms. So minus 16 plus 20 will give us positive 4. Okay. And then we just do that until we get finished, do that over and over. So now I'm taking this 4 times 5 gives me 20. So that 20 I'm going to write underneath the next number. We combine those two terms, that gives me positive 8. And now I'll do this 8 times the 5 will give me 40. So I'll write 40 down underneath my next number. And if we combine those two numbers, 5 plus 40, that's 45. And we're finished. Okay. And sometimes you'll see people underneath that last column, they'll put another little box, because this number we end up with in this last spot is our remainder, if we have one. If we don't have a remainder, we'll get a 0 there. Okay. So we're done with the division, but we don't want to leave our answer like this. Okay, we want our answer to be a polynomial. Okay, so we got to know how to decode this, right? We got to know how to write down a polynomial for our answer. So the only other thing you got to remember is that when we start writing our answer down, these are going to be the coefficients on our polynomial. That's our answer. Well, we just got to remember what power of x to start with. Okay. And when we do synthetic division, our first power of x, the degree of this polynomial we get, is always going to be 1 smaller than what we started with. So here we started with x to the 3rd. So in our answer, this is going to be the coefficient on x to the 2nd x squared, and 1 smaller. So our answer here is going to be 4x squared plus 4x plus 8. And either write down our remainder as 45, or we could write down plus 45 over our divisor, x minus 5. There's our polynomial. Okay. Question on that one? Okay, let's do another one. These are weird first looking at it because it doesn't seem like it makes sense, at least to me. Okay, let's do this one. Okay. So we'll do synthetic division on this one. We can do synthetic because the thing we're dividing by our divisor, we have a 1 leading coefficient. Okay. And then we just got plus or minus some number after that. So we're going to take the opposite of what's with the x. So it was minus 3. So we're going to write down positive 3. And then do our little synthetic division symbol. And then we're going to write down the coefficients of the thing we're dividing. We're making sure we look to see if we need any placeholders. On this one, we got x to the third, x to the second, x to the first, x to the 0th, no x. So we're okay. We don't have to have any placeholders on this one. So what's our first coefficient? What's the coefficient of x cubed? 1. Yeah, so we'll write down 1. The next one's minus 9, and then 27, and then minus 27. And if you want to, let me fix my box a little bit. If you want to, you can put a little box under the minus 27, because that'll be the remainder. Okay. We do the same process. Bring down the first number. Then we do 1 times 3. That's 3. Negative 9 plus 3. Negative 6. Do it again. Negative 6 times 3. Negative 18. 27 minus 18. That's 9. 9 times 3, that's 27. Negative 27 plus 27, that's 0. So this one went in evenly. We had a remainder of 0. These numbers down at the bottom are the coefficients on our polynomial that's going to be our answer. And this 1 is going to be a coefficient on x to what power? X squared, because the thing we divided started with x to the third. So our answer is going to start with x to the second x squared. Okay. So our answer on this one is 1x squared. We don't have to write the 1. We can if we want to. It doesn't hurt it. And then minus 6x plus 9. No remainder, so here's our answer. Okay. Any questions on that one? How many of you have seen synthetic division before this class? A few of you? Okay, several. Okay, that's more than normal. A lot of times that doesn't get covered other places. Okay, do one more. All right, synthetic division will work here. So what number are we going to write out front? 2, yeah, we got to do it's x minus 2, so we got positive 2 out here. And then we need to write down the coefficients of the polynomial we're dividing. So what's our first one? 8. And then what? 0, good, yeah, we're missing the x term, so we need a placeholder, so 0. And then the x to the 0 through the no x term, we got that, so minus 7. And that's all we've got on this one. Okay. So we're ready to go now. So we'll bring down our 8. 8 times 2 is 16. 0 plus 16 is 16. 16 times 2 is 32. And then let's see, 32 minus 7, 25. Okay, so remainder of 25 on this one. And this 8 is going to be the coefficient on what power of x? Well, we started with squared, so this is going to just be 8x, just 8x. Yeah, 8x. Got to go down by 1, so our answer will be 8x plus 16, and then plus our remainder over our divisor. Yeah, I just added it in there where we're missing the x term. Yeah, so we had 8x squared, 0x, and then it was minus 7. That's right. Okay. Now, let's see. Did one like that. Do one more. This will be our last one. If you don't like synthetic, on all of these where we're doing synthetic, you can do long division. Okay? So probably the vast majority of people, if you can do synthetic, would rather do synthetic, but there are some people that would rather do long division. So, because you can learn to do long division and it always works. Some people don't want to learn 2 ways. That's fine. All right. What goes out in front on this one? -1, yeah, it said x plus 1, so we got to take kind of the opposite of that. I put -1 out front. We've got all of our powers of x on this one, so no placeholders, but what's our first coefficient? -1. And then 1, and then -6. So bring our first number down. And we'll take that number and multiply it by the number out front. So -1 times -1 is a +1. 1 plus 1 is 2. 2 times the -1 out front is -2. -6 minus 2, -8. It's our remainder. And our original started with x to the second. So we're going to have -1x. That's right. Go down by 1. So negative 1x, or you can just write negative x. Either way is okay. And then plus 2, that's our constant term. And then plus our remainder, which was negative 8, over our divisor, which was x plus 1. Or if it asks for the quotient in the remainder, the quotient's negative x plus 2, and the remainder is negative 8.
So you use x plus or minus number as long as the number in front of the x
is 1, yeah. As long as the leading coefficient is 1, you're in good shape. So like, yes, let me hammer that home one more time. We won't do this one, but just we have this one. Okay. We cannot use synthetic division on that one. Okay. Can't use synthetic because that's not a 1. Okay. And also, this is not just an x. Okay. So synthetic won't work on this one. Okay. You can do that one. No. Yeah. Yeah. Okay, there's only a couple out of the 11 where you got to do long division. On this one, doing long division, in our divisor, we're missing a power of x. Right? We got x squared, x, and then we would need a plus 0 on the end to make everything line up. Okay, make everything line up. But we can do it then. Okay. Other questions? You good? All right. So that's it. Okay. I'll have your test grades in on Canvas here pretty soon. Okay. About an hour maybe.